All right, welcome everybody. This is the Blower Door 101 webinar. My name is Sam Myers. I'm one of our educators and trainers, our internal building science consultants. Happy to share this with you guys today, and thank you for joining us. Hope you'll get something out of it. Really can't teach the blower door process, the importance of air tightness and testing for it all in an hour. That's just not possible. So what I'm hoping this does for you is at least provide some resources that you can research on your own and inspire you to practice. And if this is something that you're new to, if you're looking to get into air tightness testing, whether if you're looking to become an energy auditor or a HERS rater, or if you're an HVAC contractor that's looking to offer this service to help figure out why existing homes are not behaving the way that they should, whatever the reason is, you're going to slip up. It's going to happen. So just get excited to fail and learn from what you screw up. And know that we're always here to help you out whenever you have questions. But the one thing that I always recommend people to do is just when you get your equipment, just try it out. Test your own house, test your own office, test a friend's house. It's riding a bike. The more practice you get with it, the better you get. But here at Retrotec, we try to make things as easy as we can as far as the equipment side goes, trying to prevent as much user error as possible. And we'll get into that as we get into the presentation. But if this is new to you, don't let it be intimidating. I know it's different probably from anything else you've ever done or any kind of service you've ever done. Once you get that first test done, everything really starts to click. It's really not that bad. So we'll get into what it all entails, how to set up a building and things like that. So before we really kick things off, I just want to share a couple of things that's new with us that you might have some interest in. One of them is we did come out with a new blower door this year. It's called the Model 7000. It's a high output blower door fan. So it's really good for testing commercial buildings, really leaky residential buildings, especially if you get into historic homes or something like that, where you need more fan power to get under that target pressure that you're shooting for, typically 50 pascals if it's residential. But the nice thing about it is it's lightweight. The fan itself weighs 23 pounds. And it comes with a power supply that'll rest on the floor or rest on the fan case like you see here. And there will be a battery version of that coming out too. So the fan will be able to run off a battery. I've been playing around with a prototype of the battery. It actually saved me in the field the other day because I was running some tests actually on some tobacco fumigation chambers and their power was bad. They had faulty grounds. And so the way that our fans communicate speed is over the grounds. So by bringing my own power, I was able to bypass all of that and still get the test done. Sometimes it's nice in new construction, if there's temporary power that's set up far away or a drop cord won't reach. I've had that happen before too. Being able to use a battery, bring your own power is really nice. But yeah, max CFM, you're looking at 700 or 7,800 max CFM, which is quite a bit. Our Model 5000 that is commonly used for residential is going to be around 6,000 CFM. But the accuracy, the flow accuracy is still within 5%, just like all of our other products. And now with our new manometer, if you input your custom calibration inputs, you can actually dial that into plus or minus 3%. The tools just keep getting more and more accurate, more and more precise. And of course, has that low weight of 23 pounds as opposed to around 34 or 35 pounds is what our other fans have been. But yeah, there's a intelligent accelerometer on it. One thing that we thought through is some safety items. So if the fan accidentally blows out of the doorway, it'll shut off. That way you don't have it blowing across the room if it accidentally comes out. There's a really precise speed control on it, so you can really dial in those pressures pretty evenly. There's an auto braking system. So for example, if you have a windy day and the fan gets going in the wrong direction, it won't happen. It'll just stop. So it'll always turn the blades in the correct direction. Yeah, it's some really nice new technology we've been able to incorporate into this fan, and that's how we see things moving forward. We also have a new podcast. If you haven't seen it, it's called the Flow Lab, where we're really trying to get some of those experts that are out there in the field that you maybe wouldn't otherwise hear from, have them come on, tell their story, talk about some tests that they've done, some of the common challenges that we run into, where the industry's going, and things like that. It's hosted by myself and our co-CEO, Ben Walker. And so we've done quite a few episodes so far. They're still rolling out. We're going to pick up recording again next month. But yeah, we've both been in the industry for a good amount of time. I'm on my 13th year of being a building science consultant. Ben's been designing air tightness testing tools since 95. So he's been in this industry for quite a bit too. But we both advocate for our codes to improve, to incorporate air tightness, to incorporate testing and verification. And so we bring these other people on that are actually doing this in the field and making things happen to share their story as well. It's just our way of connecting the industry, with more experts to hear more perspectives and hopefully learn a thing or two that you might not see anywhere else. Our first episode is actually with Harold Orr. He invented the blower door back in the 60s. And he's now in his mid 90s and still sharp and still loves to tell that story. So if you want to hear about how all of this came to be, go check out that first episode. Just basically, we just hit go and just let him talk. And it was awesome. Yeah, that was the very first days of how this all started and really why we're all here doing this. We have him to thank for pretty much everything that we do here day to day. You can find it on Spotify, Amazon, Apple, YouTube as well, called the Flow Lab. Check it out. So let's dive into this Blower Door 101. And we're going to stop maybe about halfway through. We'll take some questions. We'll also take some questions at the very end. I don't want to take up the full hour presenting. I want to leave a little bit of time. I know here on a Thursday afternoon where I am on East Coast time, I know we all have things to do. If you're on the West Coast, it's still morning to you. And I know we get some folks outside of the country as well. We'll try to keep this at an hour, including the questions. So why does this matter? When this really came to be, when airtightness testing or airtightness in buildings became important, a big driver of that really wasn't energy efficiency. That was one of them, but equally, it was also managing water. We've learned that a way that water really gets into buildings is through the humidity in the air. And if there are pathways for that humidity in the air to come through the building envelope where it might hit a cooler surface that's been cooled down by air conditioning, it can condense and then grow mold and then rot and just cause that building to not last as long as we want it to and create an unhealthy space for occupants. So water management is a really big one, and that really boils down to the durability of the building itself. So really, to make a building to be lower maintenance and to really last for generations, we have to make it airtight. And to verify it, we have to test it, and the blower door is what we use for that. On every building type, it's not just residential. We do this in commercial also with multiple fans. That we do it in industrial settings. There's all kinds of uses for blower doors to measure airtightness. This little blurb here at the bottom, really what we want to do when we build a house or really any building is, I got this from Dr. Joe Stiebrick, and he summed it up beautifully of what the goal is when we build anything, any structure. You know, we want to prevent outside air from getting in, inside air from getting out. We want to stop heat flow. We want to bring fresh air in, take stale air out, and we want to keep it all dry and keep it from blowing away. And an airtight envelope makes that all possible. You can't achieve any of those things without it, long term anyway. So that's really why we care about this. That's why this is so important. It's not just about lowering energy bills or even just making people more comfortable. It's making that building last. So these are really the way that I categorize why an airtight envelope is so important. I break it down into these 4 sections. Durability, we just talked about. I'd say that's key. We want the thing to last. Comfort is another thing too, right? We got to sleep at night. We spend just about every night in our homes. And if we're not comfortable there, we don't sleep well, we don't perform well during the day. Having a comfortable home is super important. And to really control comfort, airtight envelope is key. That allows your mechanical systems to really do their job. And that really dials into health too. Indoor air quality really falls under that. So if we're growing mold, if we're bringing in particulates, if we're sharing a lot of air with dusty vented attics or moldy crawl spaces, if we're bringing in pollutants from the outside in urban areas, we're really just setting ourselves up to feel really terrible all the time. So we really want our buildings to isolate ourselves from those harmful areas. So we really want to keep them a healthy space, and to control that, step 1 is an airtight envelope. And of course, energy efficiency, right? A lot of this really got rolling towards the end of the 70s. Retrotec was founded in 1980 because a big driver of this was energy efficiency. We had the energy crisis of the 70s that really put a lot of this forward to keep our buildings from consuming so much. So really, those are all the benefits. And if you try to solve one of these problems as a byproduct, you get the benefits of the other 3. That's one of my favorite things about this. As long as everything works together, the house is working as a system, you can't lose. So it's not as easy as it sounds. It is a bit complex. Houses, I always compare them to the human body, right? If you change one thing somewhere, you change something someplace else. So that house as a system concept is something that we teach all the time. You want to make it all work together. Because if you have a leaky envelope, then you're just allowing that to work against your HVAC system. It can't do its job if you keep introducing air from someplace else. It all has to work in concert together. So, applications. We're really just going to talk about residential here because this is blower door 101. When we talk about commercial and add more fans and networking equipment together, it gets more complex. I've got some recorded webinars on our YouTube channel that you can find about that. But let's just talk about residential right here. And there's really two perspectives that I see, a good way to split it up. You've got new construction and you've got existing, right? You're trying to accomplish different things with the same test. So new constructions, they're brand new to the world. They're babies, right? And we want to do everything up front that we can to make them last a good long time, especially if we're planning to be in that house for a while or maybe pass it down to our kids or something like that. And so the reason that we do that blower door test up front is problem prevention. We're trying to prevent anything down the road, trying to keep maintenance costs low, keep things from getting wet. And so that blower door test is going to do that. And that's why we see it in the codes. More states are hopping on board, more modern versions of the IECC year after year. I live in North Carolina. Unfortunately, we're just not there yet. We live in a really frustrating, complicated state here as far as building codes go, but one day we'll get there. But other states are figuring it out and seeing that you actually get a much higher quality product by doing this. With a tighter envelope, mechanical ventilation, it's just a much better product, healthier space, going to last longer. So we're trying to prevent any of those kind of related problems happening from down the road. In existing buildings, these problems are already happening. So we're trying to use the blower door to figure out why. Where is it happening? What do we have to do to make it better? My house is over 30 years old. It was built in 92, and it's this little icon of the old man with a cane. That was pretty much this house when I moved into it. It had some ailments going on. And so we're still working on it to make it better. It's a lot tighter than it was when we first bought it. Ventilation's coming next. But yeah, they're usually a work in progress. Older buildings that are leaky, a good way to address those is treat the envelope first and then do your mechanicals second, because that way you know what your air tightness number is and you can use that in your load calculation to figure out what size piece of equipment that it needs for it to really do its job to keep it comfortable and dry and healthy. So yeah, new construction, we're preventing problems. Existing buildings, we're figuring out why they're having problems and where the solutions can lie. So one thing that I do want you to take away from this presentation is that the blower door number that you get is not the full story. It is one part of it. And I created this diagram to really show you what you need in order to get a full understanding of the envelope leakage. And this really falls more into that existing building side, right? When you're trying to figure out why that building is misbehaving and having issues. So this yellow here, that enclosure leakage amount, that's our blower door number. That's how leaky the house is. That's what we're talking about today. But that just tells you how leaky it is. It doesn't tell you where those leaks are, how they're distributed throughout the house, or how the HVAC system interacts with them. It doesn't tell you any of that. It just gives you that one number. But you can still use the blower door and your high precision manometers to pick up the rest of these pieces of the puzzle. We're not going to get much into these other parts today. That comes into a more detailed presentation about problem solving, which maybe we'll offer one. If that sounds good to you guys, drop us a note in the Q&A or in the comments, and maybe we can do one of those later in the year. But yeah, that next step is figuring out why that blower number is so high, if that's what it turns out to be. That's when we start using smoke machines, little handheld fog emitters, thermal imaging cameras, some probes with a high resolution manometer to look for pressure differentials around the house. That's how you really use additional tools with your blower door to hunt those things down. And then the other thing is the pressure driver interaction with the leaks. And so there's 3 pressure drivers that we see that occur in buildings that cause leaks to occur. Really, to have a leak, you got to have 2 things. You got to have a hole, and then you got to have a pressure difference across that hole. If you have a hole and nothing is happening, then nothing is leaking. Once you apply wind to it, or if you pull or push on it with a mechanical system, or if you have stack effect, which we usually see whenever it's in an extreme time of the year, whether if it's very cold or very warm, we'll see stack effect happen that can pull air through holes in the envelope. But I think the one of those 3 that gets overlooked is mechanical, right? If we start shutting interior doors that don't have return air pathways, then those rooms get either pressurized or depressurized, and then cause certain parts of the house to leak harder or leak differently than other parts. And so we can use high resolution manometers with the mechanical systems running to really investigate that. That whole process is called MAD air. It was developed back in the late 80s by John Tooley and Neil Moyer. You can look it up. The paper's still out there, free to grab, and I highly recommend that you do if that's something you're interested in. And we have a full recorded webinar on our YouTube channel with John Tooley where he tells that whole story, and it's eye-opening. But yeah, those are the three parts you need to really get a full understanding of envelope leakage. But today, we're just talking about the blower door test. So for those of you who have never seen one or run a blower door test or been in the field with one, let's talk about what these components are that make up a blower door kit. It's a calibrated fan. That's what's making our air move. It creates a pressure differential, and we measure that with a manometer. And to make it all tie in and work together, we have some kind of panel in the doorway. So usually we see this expanding aluminum frame with a cloth. That's the most cost-efficient method. It gives it a tight seal around the doorway. It's designed to seal about the same as a traditional code-built exterior door. Might be a little bit tighter than most of those you would see. But there's other panel options out there too. We have a hard panel system. When we get into commercial spaces where you get some roll top doors and stuff, we make a custom panel system where you can use plywood, wood framing and stuff like that to make your own. But yeah, as long as you have an airtight panel to put that fan into a doorway or any opening really to give you that pressure differential, that's all you need. But this is the easiest way to do it right here. It's easy to carry around. Once you figure out how it works, you can have this blower door system set up in a doorway in 10 minutes or less. And we'll get more into that. So let's start back from the beginning, right? Scheduling a blower door test, what you need to have on site. And basically what you need to have is just full control of the building. Because what you're going to do when you set up, you're going to open all the interior doors. You don't want people coming in and out when you're trying to run a blower door fan, because once somebody opens a door, when you're trying to collect data, you got to start all over. If it's new construction, you want to get a less busy day. You want to work with that builder to make sure you have at least a couple hours to yourself where you're not going to have interruptions, where people are going to be running around, opening doors and things like that. The other thing is I've shown up to a lot of job sites before where it just wasn't ready. You want that air barrier to be complete, right? Because that's what you're testing. I've shown up on sites before. Oh yeah, we didn't get that window installed yet. That's a problem. That's a big hole. So just always verify that it is actually indeed ready to test. And a lot of times, depending on how that home is constructed, you can show up pretty early. If you're a home builder listening, I highly recommend you look up some of Jake Bruton's content. He's a contributor to the Build Show. What he does is he actually tests his houses 3 times throughout the build. Right when that air barrier is finished, and a lot of times what they do is the air barrier will include the floor, the exterior walls, and then the roof deck. So you can go ahead and do a full blower door test without any insulation or drywall installed. And that's a really nice way to do it. Whether on the roof deck, you can do the Monopoly style framing where you don't put on the eaves yet. Those eaves are just bolted on later. So your air barrier goes up the wall and then up the roof deck. A lot of times we see builders use zip system or something like that to create that air barrier. It's called a Monopoly style house because if you look at the Monopoly piece, that's a house. That's what it looks like. There's no overhangs yet. Those are added on later. But at the finished product, you would never tell. It would just look like any other house. It just has a really great air barrier with a fully conditioned attic space. But yeah, you can do that too. And then that way you can test again as trades come in and out, right? So if this trade is going to be making some holes in the air barrier, you can test after they leave. And if it's a lot leakier, you know where to go seal it up. That way you just have full control of what's going on with that air barrier and keep the ball rolling and not have to guess at final. So yeah, what Jake does, he tests at the very beginning, right when the air barrier is done. And then after windows and doors are put in, he may test again after certain trades come in and out, but then you test again right at final at the end to make sure you have that number that you want. But in existing homes, you don't really have that luxury, right? You're just testing what's there. You still want to be able to have full control of the house. You don't want people coming in and out. If it's a crazy rehab job site, you just want to go on a calm day where there's not a lot of activity. And calm weather helps. One of the challenges that we run into with blower door testing is we test houses to 50 or negative 50 pascals of pressure, and that's with relation to outside. Now, if it's really windy outside, then there's some measures that we can take to help navigate that. But if it's a pretty calm day, that really takes that challenge away from us. Calm days help, but if it's a windy day and that's the only day you can get out there, it's still okay. There's some things you can do. So setting up the house before you even turn the fan on, there's some things that you want to make sure you do. You want to make sure all windows and exterior doors are shut and latched. And you want to open all interior doors. So the goal that you're trying to achieve here is pressure uniformity, right? You want the entire house to get under that negative 50 pascal pressure. If you shut interior doors, you might have rooms that don't quite get there because those doors behave as dampers. Yeah, make sure all of those are opened up. And it gets a little tricky if you have attics that are encapsulated or a part of that conditioned volume. You want to include that. So you may leave attic doors open to be able to include that part. If the roof deck is part of the air barrier, you want to include that volume above the ceiling. So you'll leave those doors open. If it's a vented attic, then you'll leave the attic door shut. Similar with crawl spaces and basements. If it's a fully encapsulated basement or crawl space, you want to try to get that under the same pressure too. I know it's hard. A lot of times you don't have an access door from the inside, but if you're a HERS rater or looking to become a HERS rater, this has become a hot topic lately. I just wrote a guide and a video of how to navigate that. So that's why I put in here, just make sure you have the house set up to meet the standards that you're testing to. So with ResNet, it's ResNet 380 if you're a HERS rater. And the latest version does require you to do some preliminary checks to make sure that you are meeting that pressure uniformity between the house and these other spaces if it applies. So I'm not going to dive into that today. That's really a webinar on its own. But I do have some brand new materials that I just put out that really goes over how to check that to the standard. And then if you want to include that space as part of that infiltration volume, you can. You'll need some additional fans. But yeah, we have that out there. Feel free to find it on our website. The other thing you'll do is you'll turn all mechanical systems off. So any fans that are going to run that would manipulate pressure in the house, the HVAC system, bath fans, exhaust fans, dryers, you always want to have those turned off. If there's whole house ventilation, depending on what standard you're testing to, you'll have to have that set off a certain way. Usually there'll be a motorized damper that will be shut. You'll leave it as is. Depending on what standard you're testing to, if that ventilation runs 24/7, you'll seal it off. If not, then you won't seal it off. So just make sure you pay attention to whatever standard that you're testing to and follow that guideline. There's some safety things to take in consideration too. If there's any combustion appliances like water heaters or the furnace or anything like that, make sure they are off, or you can turn them to pilot. That's okay too. You just don't want to backdraft that device. Also check any wood burning fireplaces for ashes. I've done that before. It's not fun. If you're depressurizing the house, if there's ashes in the fireplace, you're going to pull them into the living room or whatever room that fireplace is in, and it makes a mess and it sucks. So always check fireplaces. And then another thing too is if you're testing an existing home that's having some indoor air quality problems, like maybe if there's mold growth, and if that mold is growing anywhere along the air barrier, exterior walls, floor, ceiling, it might be a good idea to pressurize instead of depressurize. That way you're pushing that stuff out instead of drawing it in. Pretty much all the blower door standards allow you to test in either direction. Depressurization is my favorite because if you think about it, bath fans, kitchen exhaust dampers, we're not allowed to seal that stuff off, but we also don't want to blow them open. So if we're depressurizing, we're just pulling those dampers shut because that's leakage that we don't want to count. But if we have this kind of situation where we might have a ashy fireplace, dirty fireplace, or if there's mold growth, a positive pressure test might make more sense here to prevent any further damage. And the only time that we recommend not to run a blower door test ever is if there is vermiculite insulation in the attic. Zonolite was a primary manufacturer of that. It's asbestos in that material. It kind of looks like a crushed gray denim. We have a blog article on our website that you can find about that. If that's something that you come across, I don't recommend blower door testing. I would wait until the proper abatement is done to get rid of it before you run a blower door. You don't want to disturb that. You don't want to make it airborne. So that's the one scenario where I say, don't do it. Anything else, you can navigate around it, but don't do that. But yeah, just check for that. Older houses, if it's common in your area, just pop up in the attic and take a look and see if it's in there. And if it is, there's a Zonolite attic insulation trust that still operates today. So they actually provide some funding for abatement. Let your homeowner know about that. So let's talk about some equipment setup, the steps that we do here. We install the door frame. The frame just clips together. It's 4 pieces, the 2 sides, the top and the bottom. And then there's 2 crossbars in the middle. I always put the crossbars in after I put on the cloth. Some people do it before. It's personal preference, but I always wait to do that later. I just think it's easier. But yeah, you'll pop those frame pieces together and then you loosen the little knobs on each side so that way it can expand both horizontally and vertically to fit that doorway. And then you can tighten them back down to lock it into place. Then after you get the cloth on and have it fit in the doorway, we mount the fan and then we connect the manometer. And I'll show you our gear. We make everything color coded so that way you're confident everything's getting plugged into the right place. So here, yeah, here's just a little clip of what the frame looks like. They're numbered, so that makes you make sure you put everything in the right area. Even the crossbars are numbered 5 and 6. And if you take it apart, you just have to rack it apart like that. It just comes apart in one motion, so you don't have to break your thumbs. And we make three frame sizes. So standard, large, and then we actually have a smaller one for windows when you use our duct tester fan as a blower door. You can do that too for passive house or something like that, or really small, tight houses or condos or apartments. But yeah, the frame just clips together, just match the numbers up. It's super easy. And then the cloth, there's different ways you can put the cloth on. My favorite is just to spread it out across the floor, get it all laid out. It Velcros on. So you'll do this after you get the frame sized up into the doorway. There's little Velcro tabs. Always make sure those are out. And then there's a little pocket at the bottom that holds the bottom piece of the frame. You'll just Velcro it in, and then you just wrap it like a present. You'll just start at the bottom, work your way up, use those little Velcro tabs to wrap it, keep it nice and neat. And then you'll pull that top down. There's two little Velcro tabs up there that stick back to itself. And then you can pop it back into the doorway. There might be some last adjustment that you need to do. If you've noticed that it's a little loose, you can just go around, loosen those little knobs, step on the bottom bar, pull it up to get it nice and tight. Same for the width of it. You may have to readjust that. You just don't want that thing to go flying off somewhere. But after you get it tight, you can flip these little cam levers, and that tightens it up more into the doorway just to make it nice and snug. And then here's where the crossbars go in. So one of those crossbars, that's number 5. It does matter. They have to line up with those holes. Number 5 goes right underneath the pockets of the door, right over the hole. That's where your fan is going to hang from. And then number 6 kind of goes more at eye level. You can see there right above the window. And they help secure the frame better into that doorway just to keep everything stable. Gives a place for the fan to hang from, and a place up where you can get the gauge out of the way of the fan off the floor to attach it. And you can see as we put the fan in here, there's a little Velcro strap that goes around that bottom crossbar. I usually just want it about an inch or two off the floor is what you're looking for. And if you're using our duct tester fan as a blower door, that's called the Model 300. Like I said before, it's great for really small apartments or small houses, or really tight houses like passive house. You can get away with using that fan. The tighter the building is, the less fan power that you need. So you can get away with this little duct tester fan on really tight structures. But if you're going to use that, you can get a special cloth that has a smaller hole for it. It comes with a little red ring. It's a quick connect collar. Put that in the doorway first. You can cinch it down, and then you can pop the fan into that quick connect collar. And then you just hang it from that bottom crossbar just like you would any other fan. So the equipment setup, we're still on that. So that's our frame and our cloth, and then installing the fan. Next is the manometer, right? And so I mentioned before, we made everything color coded. And so when you're running a blower door test on a house, you'll always have 2 hoses that you'll hook up. There's red and yellow. And we made it as easy as we can, right? Red hooks up to the red cloth, yellow hooks up to the yellow fan. And there's the same ports that you see on that manometer are also on the fan and the cloth. So you're just matching those together. So we tried to make that as easy as we could. There you can see on the fan, you can see that yellow port that's there at the bottom. Your tubing that comes with your system, that's what it looks like. It's all bundled together. So your red tube, your yellow tube is bundled in along with the yellow Ethernet cable. That's what allows the manometer to tell the fan what to do. So that's your speed control. So you can control everything from the manometer. There's a manual dial on the fan, but you don't have to use it. If you have that speed control cable connected from the fan to the top of the manometer, everything can be operated straight from the gauge. And then there's also a power cable that we include in there too. We call that the umbilical. It's all bundled together, your tubing, speed control cable, and power cable for the manometer. We put a USB port on the fan top so that in case you forgot to charge your manometer the night before, you're not dead in the water. You can still run a test, so that way you can power it off the fan. Yeah, that's a nice feature that we added a little while back. And since we're on this topic, I am going to exit out of here and actually pull up my manometer so you can see it, so we can see how to set that up.
Do you want to pause for a few questions here while you
Yeah, I
do
was just
that?
about to ask that. Thanks, Noah.
Yeah, so there's a couple great ones. One of them is, do you recommend asking clients if anybody has respiratory issues or asthma before running a blower door test? And so I did when I was running tests. I liked to do that if I was doing an existing homes audit and there were like kids and people at home with me. It can't hurt to ask that question, and if they say yes, then that would be another scenario where I might recommend a pressurization versus a depressurization test. You're probably not going to cause issues, but to be overly cautious, in my opinion. It's good to do. Do you agree with that, Sam?
Yeah, I agree with that. And I think part of that too just depends on where you live and what time of year you're in. If I'm here in the southeast in April where we have a ton of pollen, I don't know if I'd want to pressurize to directly blow that stuff in. It just depends like what their allergies are. And plus, if we're just running that fan for just a few minutes and they live in the house full time, they're probably not going to see much of a change. If part of the reason that you were there is to help solve that problem, if their house is making them more sick, it's the benefits of having that there. Maybe head out for a bit, go outside, or because what you're doing really isn't going to cause much of an issue on the house. That 50 pascal pressure that you're doing is equal to a 20-mile-an-hour wind hitting the house at all sides. So it's really not much more than what the house is going to experience anyway, if there's some inclement weather outside. So it's good to ask if they're concerned about it. I would maybe do that before I go that day. So that way they can plan to maybe be somewhere else if that makes them feel better.
Yeah, and try to frame it in a non-alarming way. Don't
Yeah.
make it
And that's
sound
what I
like we're
always
doing a
explain
dangerous
too.
test.
Yeah. Just the way the test is designed, the way that 50 pascal number came about is, when airtightness testing was first being researched decades and decades ago, the scientists were trying to replicate natural conditions. And then they soon found out that's not a real thing, right? Because natural conditions are constantly changing. So they were starting with 4 pascals and wanting to test under that. On windy days, you can't do that. It's impossible. And then they moved to 10, and still at 10, if you have wind outside, it's just going to knock that number all around. And then in Europe, they just said, look, let's just take it up to 50. That allows us to get full control. And so that's where 50 pascals came from. So it's enough to get full control as far as pressure goes over the building, but not enough to really cause any damage. 20-mile-an-hour wind is really nothing. Houses experience that all the time. So that's usually a way that I explain it, right? We're talking about a 20-mile-an-hour gust hitting your house for just a few minutes. That usually takes any concern away.
Yeah, so another good one. What is your method for measuring complex conditioned attic volumes? So that one's a tricky one. It usually, I like to just break it down as much as I can. It all kind of breaks down to a triangle, a rectangle, or a circle when you look at it at the end of the day. If you have plan set available, using like a PDF reader or SketchUp might be helpful, or if you have a really good relationship with the architect, you might be able to ask them for it. Do you have anything else, Sam?
Yeah, plans are really going to help you there if it's new construction. And the PDF reader is nice. Like if you use Foxit PDF, there's a scalable drawing tool. So if there's any kind of dimensions that aren't on the plans, you can add them yourself quickly and easily to figure out what those volumes are for those extra spaces that aren't just part of a rectangle. If it's an existing home, go ahead and purchase a laser distance measurer. That's a quick and easy way to get some of those measurements on site that you need to get your peak height, your eave height, and things like that. But yeah, that's what it comes down to. It takes a little bit more time for more complex houses, but just make sure you give yourself that amount of time to get what you need out of it.
Awesome. Last real question, then we've got a few comments. If I'm performing a blower door test as an insulation contractor for pure thermal perspective, would it make sense to leave attic hatches and doors closed as that is the typical state of the house? Or would there still be a benefit of getting those open? I think that all depends on the attic configuration, whether it's conditioned or not. But if it's a conditioned attic, which I'm assuming, you'd still want to add open those up because we're trying to get an idea of the leakage, air leakage, which is another component of the thermal performance of insulation, if it especially if it's like a cellulose or a fiberglass, a fibrous insulation. But I'll let you take that one.
Yeah, if that attic is supposed to be encapsulated and if that attic space is supposed to be a part of the conditioned volume, there's some quick checks that you can do to see how well it's sealed up. If you just crack the attic door a little bit, if you have a smoke machine, a little handheld fogger like our air tracer, you can run the blower door and there if it's sealed really well, there really shouldn't be any movement there at the attic hatch. So if you just do some puffs of fog right there. If you're let's see, usually what I like to do is pressurize. I think it's easier to watch it go away. And so if you see that fog just shoot up into the attic, it's a leaky attic that shouldn't be. So that's just a quick check, and then you can go from there to see where those leaks are. Usually what I see if it's spray foamed, it's almost always really leaky at the eaves, at the overhangs. They're just hard to get to. That's where I see a lot of failures happen. But yeah, if you have a good day where you can use some thermal imaging, that helps too with evaluating spray foam jobs. But if it's the Monopoly style house that I was talking about before, those almost always work out better because you just have much more control of what you're air sealing from the outside. But yeah, spray foam, I've tested more bad jobs than I've tested good. There's just some places that are hard to get to, and there's just so many variables about the actual chemicals that you're installing that have to be right. Was that person well trained? Was everything prepped appropriately beforehand? There's just so many things that can go wrong. But testing for it is pretty easy. Is it leaky? Crack that attic door, see if you have movement, and then go in and see where it is. But yeah, there's some different ways you can play around with both scenarios that way to get an idea of what's going on.
Yeah, so I think there's Joe Medosh is in the audience. He wanted to
Yeah.
reiterate that healthy homes through controlling contaminant pathways, that's one of the key things that a blower door does. I think you did touch on that after he made that comment. And then the occupant is part of the house in a system, like the system of systems. And then we've got some comments that we'd love to see the advanced class. We're not going to be able to show you the calculating the volume with the application today, but maybe we could include that in an advanced class.
Yeah.
And yeah, I think that's all. I'll be typing up some more responses here, but
Cool. Joe, thanks for joining. That's great. Joe used to be the Retrotec guy. I took over for him a while back. We're still good buddies, but yeah, that's been one of his things here lately is the blower door is also used for finding contaminant pathways for indoor air quality problems. Absolutely. So let's dive into the gauge a little bit just to help you show how to navigate to get through this thing. This is the DM32X manometer. This is the current manometer that we manufacture. And for blower door testing, duct leakage testing, this is the only one that we're manufacturing. The previous one was the DM32. It came out in 2013, and the 32X just came out a couple of years ago. The interface, as far as the gauge, they're very similar once you get into the gauge itself. But once you launch the DM32X, you'll get to this home screen. There's some other parts of it where you can connect to Wi-Fi, Bluetooth, and things like that. But I'm just going to go over the basics of just how to do a test. You'll notice there's 3 apps here at the bottom, and the whole device is built on an Android platform. So that way we can always push updates over the air, add new features and things like that easily without you having to send it in or hook it up to a PC. You can just update it over the internet just like you would your cell phone. But right now we have the Gauge app, so that's going to open up the manometer interface so you can run a blower door test. We have our cloud, which I'll talk about in a little bit. And Joe Medosh, this was actually his brainchild when he was at Retrotec. And it's an automated testing and reporting app. And if you get into blower door testing, I recommend you use this and run your tests in this. You can run some manual tests first to see where you are, but then use our cloud to report it. It'll save the test, save every bit of information about that test day, save the building information, and it'll tell you if you're testing the code, if it passed or failed. So building officials love this. If you're a HERS rater, it's something quick and easy to send over to your provider. You don't have to write anything down. It just does it all for you. And then the third app that you see is a resources app. And so that actually has the full manual for the blower door system, for the manometer, some quick guides on how to set everything up, some brief illustrations to cover what I'm covering today, as well as some videos broken down to help you walk through what to do. If you have somebody new, show them that app and how to get to the video. So if they get out there and get stuck or second guessing themselves on setting something up, they can literally just have the manometer tell them what to do. And you do not have to be connected to the internet to pull those videos up. They are baked right in. So we have it for blower door testing, duct testing, everything else that we make. They're all broken down into sections. You can open it up. There's a menu. Each video is 30 seconds to a couple minutes long. So that way you don't have to skim through a whole long video to find what part you need. You can actually just find the chunk that you want. So let's open up the Gauge app. So this is how to just manually run a blower door test. This allows the gauge to communicate with the fan. You can control building pressure, fan speed, however you want to do it. And so at the very top, you'll notice that it does have your serial number there. That comes in handy a lot, especially if you're keeping up with gauge calibrations, which you can see here when the last time this one was calibrated, it was last spring. All that's up there. So if you have a building official wanting to know that, you can just show them right there. And if you're connected to the internet with it, you can actually click on that and pull up the calibration certificate right on the screen. And then you can see what version of the gauge app that you're running. If you call in tech support, if you're having some issues, if something isn't behaving correctly, that way you can quickly see, to tell them what version that you're running or to see if you need to do an update. So we have channel A and channel B. This manometer is essentially two manometers built into one housing. So we have four ports that we can connect hoses to, and it's split in half. So there's two sets of positive and negative. So channel A is going to be what's going to be reading your building pressure. So that red tube that connects to the outside, that tells us when we've gotten to that 50 Pascal pressure target, or if we've gotten there. Channel B is going to be the other side. That's where the yellow tube is going to connect to the fan. So that's our fan pressure. And the blower door system works on pressure, right? There's no airflow sensors or anything like that. It is 100% pressure. And then it does math on the back end to figure out flow. So if we know fan pressure, which we do, we're measuring it right there at the center of the fan. When you plug it into that yellow port on the fan top, you have tubing that goes through down to the center of the fan. That's where that pressure is actually read. The fan pressure, and if you know the hole size of the inlet side of the fan, that area of the hole, depending on which configuration you have the fan set to, then you can calculate CFM. And so if channel A is at 50 and we're getting a flow on channel B, that's our CFM 50. An important thing to remember is when you're running a blower door test, however you have your fan set up, so this is ring A, our manometer needs to match that. So we have photorealistic images of whatever fan that you're going to use in here. So if you're testing a tighter house, you'll have the fan more closed off. So let's just say if I'm testing a relatively tight house and I need to get to B2, then those are the exact two holes that I need to have open. Make it match that picture exactly, because that's how the fan was calibrated at the factory. So that is important. So make sure you're just matching those exact same two holes. You can't just pick any two holes. Make sure it's those two that are in the picture. Same for B4. I see a lot of people post their blower door tests on social media, and this is the one thing that I see constantly that people get incorrect. You can't just pick whichever holes that you want. It has to be just like that. And so let's talk about what these mean. We have these different hole configurations. The tighter the building, the less airflow that you're going to be moving through the fan. So the more closed off the fan will be. So we have to do this because we have to force those fan blades to spin faster to build up pressure inside the fan shell for the manometer to take an accurate reading. And so we achieve that by choking off the inlet side. And so that allows us to be able to use this larger fan to test smaller or tighter spaces. And so you might be asking, if you've never done this, how do I know, which range to set to? Each one of these configurations are called ranges, right? Because each one has a certain flow range that it can handle. So let's just say we start on open. And if we're going to set our pressure, we can hit set pressure. We put some hotkeys in here of the pressures that are commonly used with this gauge. 50 pascals is what we're always going to use for running a blower door test. Whether if it's positive or negative depends on which way the fan is facing. So if it's going to be negative, you'll have those ranges facing you. That's the inlet side. That's going to exhaust flow out. If it's positive, the fan will be flipped around and it'll blow air in. So if I run it to 50, you'll see the speed will ramp up. We can see the speed's at 100%. This gauge isn't connected to anything. It's thinking that it's running a fan, but there's nothing attached to it. So it told it to go up to 100, but it's still not seeing a pressure. So if you're not getting to 50 pascals, then that means you need to go up a range, right? Usually you'll see that at a lower range. If you're doing that on open, wide open, and you're not getting to 50, I would go back around and make sure that I checked all the windows and doors and make sure nothing came open. It might just be that it's a super leaky house and one fan won't do it. I've tested historic homes that were insanely leaky like that. And the way we interpret air leakage is we have CFM 50, our CFM flow at 50 pascals. We also have ACH 50, which is commonly required by code, which is air changes per hour at 50 pascals. So that question earlier about how do you measure volume in complex floor plans, that's where you need the volume of the building to get ACH 50. And you can put that in here. So if I just tap on channel B, it'll give me some different outputs. There's lots of them. This gauge is used for all sorts of stuff, but whichever ones I use the most, I can click on this heart and I don't always put them at the top. So if I do ACH, I can change my volume. So this was a pretty good size space that I tested last time. You can change this to whatever you need it to be, depending on what the volume of the space is, because you're going to need that to get ACH 50. So there, see, I can see that new volume there. So that's a nice thing too, is when you have ACH, you can see the volume there that you're referencing to make sure that you have the right number. So depending on whatever number you need, whether it's CFM 50 or ACH 50, if you're not getting to 50 pascals, usually what that means is that you need to open the fan up more, or something's going on with that building to make it not get to that test pressure. So it's either just too leaky to test with one fan, or you left some windows open or a door blew open or something like that, or somebody, came inside and didn't shut the door. Or I would go back around and make sure that everything with the house is set up properly. It could also mean that you might have just forgotten to plug in a hose somewhere, where we see that happen too. So just take your time, don't rush, make sure everything is plugged up the way it should be. If you see something weird like that happening and it just seems out of place, double check your setup. Make sure all those tubes are plugged in the way that they should be. Make sure your speed control cable is plugged in. That's usually what's going to happen. I see that more often than I see weird things happening in a house. It's usually how you set the equipment up. So just take your time, double check yourself, make sure everything's plugged in where it's supposed to be. Now, if we get the opposite happening, let's just say we have the fan set on a certain range, it can be open if we think it's going to be leaky. If I do get to 50 pascals, but I'm still seeing 2 dashes on channel B, that means the fan blades aren't spinning fast enough for the manometer to take an accurate reading. That means we need to choke it down. So maybe I'll go down to ring A. And so if I do that on the fan, if I put ring A on, I need to make sure I do that with the manometer too. They always need to match. So that's really how you need to know. If you're not getting to 50, open it up. If you're getting to 50 and not reading a flow, then you need to go down. That's really how you figure out how to land on what range that you need to be at. And sometimes you'll see there might be a little overlap between certain ranges. You might get a reading on, I might get a reading on ring A, the fan speed might be low, or I might also be getting a reading on B8 and the fan speed will be higher. If that's happening, if you notice you get a reading on both ranges, stick with the lower range, right? You want those blades to be moving. So anytime you find yourself in one of those in-between range places, go with the smaller one. But it doesn't happen often, but it happens sometimes. But yeah, you can see here too that the fan still thinks it's running. I just hit stop to make it stop. There's other ways you can control the fan too. That's set pressure. That's telling the building to go to 50 pascals. I can also go to set speed, or I can control fan speed here with the slider. If I go to set speed, I can tell it to go to 25% or whatever percent speed. That's 25% of what the fan can do altogether, right? I can adjust that here too, like up 10%, down 10%. And if I go into my settings, I can change this 10 to 1% or 5%. I can change that jog amount to whatever percent that I want to. This comes in handy. Say you've already gotten your blower door number, it's 50 pascals. Say it's like 1,000 CFM 50. If you want to go run around and check out some stuff and not have the fan fluctuate if you open an exterior door, like if somebody walks in and out, if you have your fan running when it's on set pressure and somebody opens the door, that fan's going to just run wide open because now there's a huge leak. If you don't want that to happen, you can go to set speed and it'll just run at that constant speed the whole time, whether somebody opens the door or not. So if you're doing further diagnostics after your blower door number, sometimes that comes in handy. And we'll talk about this in a minute, but since we have the gauge open, before you even run a blower door test, like after you set it up, you're going to do this thing called a baseline reading. And that's where you are trying to remove any wind activity that's happening outside. So I talked about at the very beginning of this webinar that wind is a challenge, and we cancel that out by running a baseline test. Baseline, bias, pressure, those are interchangeable terms. They mean the same thing. So we have a button here called bias, and that's how you take your baseline reading. And you do this with the fan covered, right? So you can have all the ranges plugged up, or there's a little red shower cap cover that covers the fan entirely. You can use either way. It doesn't matter as long as it's covered. And then you click that bias button, and there's a little record button, and you just let it go. And all it's doing is measuring the pressure difference between inside and outside. So if there's a high stack effect, it'll take that into account. On this little graph here, if it's stack effect, you'll see it hold like a constant. If it's wind, let's see, I can play around with one of these pressure ports and yeah. If it's wind, it'll spike up and down like that. But we added that little graph there because having that visual just shows you how windy it is. If it's a really calm day, 30-second baseline is okay. If that line's not moving around anywhere, yeah, that'll work. If I do see a lot more activity, I'll let it run longer until that average kind of starts to hold a little bit. Let it get a few gusts in to average those out. And so whenever you get your baseline where you're okay with it, you just hit that record button again. It'll ask you if you want to save it. Yes. And then you can go back. And so it'll have that average baseline there for you to show you. If you can't remember, if you had a lot going on, did I take a baseline yet? You can see right there if you have one or not. And to get rid of it, you can just go back into BIOS, clear it out. Yep, clear. And then it'll be gone. So yeah, that's important. Always remember to take your baseline for a more accurate reading. And plus, your standards are going to require you to do that too. So that's really the basics on that. The other thing too is to make sure you have the right fan selected. So this is a Model 6000. This is one of our higher output fans. The fans that you will likely use in residential, you can go to change device. These are all the models that we have. There's a lot to choose from here. Our older fans, our newer fans, our flow box to read exhaust fan flows. Our competitors' fans are in here too. But the Model 5000 for residential is likely what will be used. So once you select the fan, then you can select whatever range that you want. But if I go back, you can see you can favorite your devices too. If I have a 1000 accidentally favorited, I don't have one of those, I can remove it. And I can customize that so that way I'm not having to scroll down and hunt for things. So that's the quick and dirty on the manometer, navigating it, how to get the reading that you need out of it. So we'll get back into this. And I just wanted to show you on the cloth up around where you would hang the manometer. The manometer has a belt clip on the back of it, and there's a little Velcro pocket on the top crossbar. That's where it'll hang. Right around there, you'll see there's a little tube that comes out with a red port. That's where you plug the other end of your red port in. And the cloth it branches off and it's teed on the backside to reference the outside. Helps on windier days. That way you're not tossing the tip of a hose into a puddle or something like that too. It just keeps it consistent. Yeah, that's really the timeline of what we're looking at to run a blower door test. We're going to prepare the house. We're going to take our baseline measurement. We're going to run the fan. We're going to record our data, write everything down, and then return the house to normal. So anything that we turned off, set thermostats back, turn water heaters back on, leave the house the way that you found it when you got there. And then analyzing the results, I mentioned that rCloud app. Get familiar with that. It's just a nice way to not have to write anything down on site. You'll always have your data on you. You can have your test history on your phone. You can access it from our website too by logging into the portal. It takes multiple baselines, averages them together, takes multiple blower door readings, averages them together. It just does a really nice job of automating that whole process for you. And then at the end, it'll give you a PDF report. You can tell it what the pass fill requirement is. So let's just say 5 ACH 50 is what you have to meet. You can enter that in rCloud up front, and it'll tell you right there on the top of the page if you met that or not. So really easy for building officials to understand. It says pass or fail right there, really big, but it has every bit of information about that property, making sure you're at the right residence, the right address, the right coordinates. It's all there. And you have access to this anytime you want. So if you're doing multiple tests on a house, like I was talking about before, you can have all these reports to see how it varied throughout the build. Or maybe if you're doing weatherization on a house, you can do a pre-test, air seal, post-test, and see how much you brought it down and be able to just neatly keep all that organized and together without having to really do anything. If we're finishing up a blower door test, we'll take our equipment down, we'll restore all of our systems, and we'll document our findings. If we get a really low CFM 50 or ACH 50, that means the house is pretty tight. It was built well. Maybe it was pretty simple and there wasn't a lot to screw up, or maybe it had received some weatherization over the years or something and had been made tighter, or who knows, maybe it's just not as leaky as you thought it was. If it was an existing building with problems, maybe the problem lies someplace else. Or if it's leak, or if it is a high CFM 50, high ACH 50 number, that's when some extra diagnostics like this is going to come into play. So this is actually an attic knee wall. The knee wall is actually a little bit off screen over to the right, but there's a huge gap between the upstairs floor and the downstairs ceiling. where attic air is just pulled in between floors. So we were able to locate that with a smoke machine there with the blower door running. But there's other ways we could see that too. But yeah, this is what those low readings versus those high readings actually mean. Both of these are knee walls. This attic here had the exact same problem that this one did. This one's just been treated with rigid foam board, sealed to the wall, going all the way down to the ceiling below. Really brought the blower door number down quite a bit on that house. So that wraps us up. If you have questions, if you want to dive into some stuff more, our YouTube channel is just packed full. I have a series called Technical Tuesdays that really dives into the weeds on different things, how to find leaks, basic mechanics of how this stuff works. You name it, it's in there. Our podcast can be found there also. Our different episodes can be found there as well. Previous webinars that have been recorded on different topics. Feel free to dive in. And yeah, Noah, do we have any more questions?
Yeah, I think I've answered most of them, but the one, if you go back one slide, it actually ties into this slide very well. If you ever notice that your volume number was incorrect, basically the comment was that ACH adds a step that you could forget or have some error. So it's always a good call to take a picture of the CFM as well. But so if you're getting a high or a low CFM or ACH 50, it is always a good step to double check that your range settings are correct and everything as well. And if you do end up with an incorrect volume or an incorrect range setting on your gauge that you notice after the fact, don't panic. There are some things that we can do to help you with support. As long as you got a 50 Pascal and some number on that channel B, we can likely help you out.
Yeah, and there's a program you can download off our website too called Virtual Gauge. And it's basically just the interface of our DM32 previous manometer. We haven't quite updated it yet for our current manometer, but you can still use it. And basically, you can put it in simulator mode and then just fine tune it to replicate what you did in the field. And so if you chose the wrong range, you can put what you did in the field, go back, change the right range, and it'll give you the correct output. Or same thing with the volume. You can put the incorrect volume in and then go back and change it and then see what the correct answer would have been. Virtual gauge is what that's called. You can download it right off of our website. I think it's under pressure gauge. If you find it on our website, you'll see it there. It's free to download.
Yep. And Joe wrapped it up nicely. He said, always take a snapshot of the gauge and the fan so that you can sleep well at night. I think that's a good final note.
Yep. Yeah. Good point. Do we have anything else?
We had a question about the airtight, very hard to get airtight rated bath fans, which is working properly. That is a good point. Getting a bath fan that actually both works properly and has airtight like damper systems. Do you have any recommendations or thought on that?
Yeah, I actually had this problem. I went and tested a house last week that was having that issue. We were feeling warm air blowing back in, and we could see it on thermal too. And then we had another bath fan that didn't. And that bath fan actually had a motorized damper on it that would power on when you turn it on. That had a nice seal on it. I've also gotten mixed reviews. There's a product made by Tamarack called the Cape damper, and it's basically a fabric damper that once it feels a slight pressure differential, it'll just pull itself shut, but it'll only go one way. I've had people have a lot of success with them. I've had other people say it doesn't really do a whole lot. It just gets stuck open, but it could be worth a shot. But yeah, it's interesting. Check it out. It's called the Cape damper by Tamarack. It's completely different than anything else you've ever seen if you've never seen one. But I would think it would work for most instances if it's installed in the right direction. That could be like a common issue with that. Maybe they just flipped it around the wrong way. But once it does close, it does get a nice airtight seal. There's nowhere for air to go. But yeah, the dampers that come on those builder grade bath fans are pretty crappy.
We do have one more here. For heat pump water heaters ducted to the outside doing a depressurization test, is it recommended to seal the supply side of the duct of the water heater? I've encountered some water heaters that don't draw air through the unit and others that are very leaky through various houses. Is this a byproduct of proper heat pump install or air barrier testing prep? Yeah.
I'm trying to picture the scenario in my head. So the heat pump water heater is ducted where?
I know some of them do duct to outside so that they vent their air somewhere else, is my
Okay,
understanding. They
gotcha.
pull their supply air so you're not as impacting the space that the heat pump water heater is in as much. And
Okay.
yeah,
Yeah,
it's
I
kind of
mean, if you look at a lot of the test standards that we see and for code 2 are based off that ResNet 380 standard, you're really not supposed to seal stuff up like that. If that's how it naturally is, then that's how we have to leave it. That's just leakage. There's just needs to be a better way to seal that off. whenever it's not running.
Yeah, that's an interesting one. Basically, the only exception to that rule is 24-hour continuous ventilation.
Yeah.
Those are the systems
And
that can be taped up.
I doubt that's going to be running 24/7. So that
Yep.
wouldn't, yeah, that's not going to count for that. So yeah, you really wouldn't be allowed to tape that off. That would just count as part of your blower door number.
Yeah, I think that's the last of the questions.
Cool. If you think of any more after this, feel free to reach out to us. Call our support number. You can find that right on our homepage, retrotec.com. You can email Noah and Lee and Tim over at support@retrotec.com. Feel free to drop me an email too, sam@retrotec.com. Always happy to help you out anytime we can. This is what we're here for. But really appreciate you all joining us. And yeah, I guess we'll put together a next level webinar for locating leaks and maybe talking a little bit about the mat air side of things that we can do later on this year.
Stay tuned for Blower Door 102.
There we go. Cool. We'll go ahead and wrap this up. So yeah, thanks again, everybody, for attending.